Hello guys, so today in this video I will be talking about how we can design half adder using VHDL programming to implement on FPGA board. So this will be like first tutorial on this regarding VHDL programming for FPGA boards. So okay, so I would like to go from example, like exactly where does this half adder is like used. Okay, so this is half adder is basically used in order to add a single bit number like 00, right, and 01 and 11. Okay, okay, like if we add 00, sum will be 0 and carry will be 0, right? So this will be like sum and this will be carry. Okay, similarly if we add 0 and 1, it will be like sum would be 1 and carry will be 0. So this is like sum and this is carry. Okay, so when we add like 1 and 1, so we'll get 0 as a sum and 1 as a carry. So this is like sum and this is carry. Okay, okay, so so using same strategy, now we can make a truth table for half adder. Okay, so now we'll be making truth table. Okay, so just give me a few minutes. I'll just make a table first. Okay, so there would be like input and output, right? So in input there will be again, like we'll be taking 2-bit number, I mean like a and b, two variable. So for output, there again there will be like two output, sum and carry, like as what we have done above, right? So for two variable there would be like four possible combination, like 0 0 0 1 1 0 and 1 1. Okay, so when we add 0 0, this 0 and 0 will be getting sum as 0 and carry again 0, right? So if we add this 0 and 1, we'll getting sum as a 1 and carry 0. So similarly this 1 and 0 will get 1 and 0. So but when we add 1 and 1, we'll be getting 0 as a sum but carry will be 1. Okay, so this is the truth table for half adder. So using so from this truth table, now we can get the boolean algebraic function for half adder, which will be used to draw the schematic diagram or digital logic circuit for half adder. Okay, so this function is very much important even when we start writing the code, VHDL code for VHDL code, right? Okay, so now we'll be using kmap. Okay, so we'll be calculating boolean functions using kmap. Okay, using kmap. So again, since here are like two output, sum and carry, so we have to make a two separate kmap, so that we will get two different functions for separate function for sum and carry. Okay, so I'll just first take sum, output of sum, and just make a kmap for sum, right? Okay, so for sum, okay, like I'll just first make a box. Okay, so here would be a and here would be b. Okay, so there would be like two possible values, like for single bit number 0 and 1, and again 0 and 1, right? So I'll be writing this number, okay, so I'll be writing this number. I'll substituting this value on the kmap, so I'll be getting like 0 1 1 0. Okay, 0 1 1 0. So I presume you guys better know about how to make a kmap from the truth table. and how we can get the boolean function for, I mean like how like there is a a procedure like how we can encircle these ones, and from that we can get the boolean function, right? So I don't want to waste time on like describing more about K-map, so I suggest you guys to go and watch some tutorial on YouTube, so that just watching few videos you'll get to know uh, pretty well. So now I'll be more focusing on so since I'm focusing more on like VHDL program, so I don't want to take a lot of time for this. Okay, so now we'll encircle this one, right? So I mean this is the only possible way of encircling one. So I hope you guys understand this. So okay, so you better go, if you are like confused with this what I'm doing on this game map, you can go and watch few videos. Okay. Okay, so for some if we take if we take this one, right, then if we look at B is like 0, right? So that is B complement. And if we look at A, then there is uh, A is 1, so therefore we'll write A and B dash. Okay, so now if we go with this one, B is 1 and 1 is 0, so there will be like A dash and B. Okay, so I hope you guys know exactly what is this I mean this function like it is like it is a function for XOR gate, right? So it will be like A XOR B. So if we like symbolically we can write A XOR B. Okay, so this is what the algebra boolean function for sum. Okay, so now we'll go for we'll just to find the function for carry, we'll take this output and then again make a separate K-map for it. Okay, so okay, so now we'll take carry K-map. Okay, okay, so first I'll just make a template for, okay, so again we'll take A and B, and again this has two possibilities, right? Okay, so what are the values? It's 0 0 0 and 1, right? 0 0 0 and 1. Okay, so now we have to encircle this one, right? So now the function for carry would be like, if we take this one, there is only one possible one, right? So if you look at B, there is 1, and if you look at A, there is again 1, so there will be like A and B. Okay, okay, to summarize like what we have got the function now, like we have got sum equals to A XOR B, whereas carry is like A and B. Okay, so now we can make okay, so we have got like 3 4, right? Okay, okay, so using this boolean function now we can get we can make the logic circuit for half adder. Now we can make a schematic diagram or logic circuit for half adder, like, okay, so using the same these functions. I mean this some function is so much important, like this will be needed even when coding this VHDL programming, right? So even for schematic diagram also this is very much important. So there are like two input, okay, A and B. Okay, so now for sum there is A XOR B. Okay, now we'll do this, and I hope you guys know, right? This is like gate for XOR. So now here we'll be getting sum. Okay, so now for carry it is A and B, so we'll be using AND gate, A and B. So this is carry. Okay, okay, so this even now we have got this this logical circuit, digital logic circuit for half adder. Now we can go and use the same function and write the VHL code. So but directly jumping before jumping into the VHL like coding, I would like to take a little bit time just to explain about the structure for VHDL programming. Okay, okay, so okay, this is it's a 5. So VHDL, okay, programming. Okay, so Okay, so in VHDL programming, like there are like three sections, like okay, like if you take VHDL, like if I make tabular in a tabular form, okay, this if this is a VHDL module, okay, so it has like three sections. So first is library, okay, library declaration. So I will explain more when while writing these VHDL programming. So okay, so just for basic understanding, I'm just making this thing, okay. Okay, so second one is uh, entity, right? So in entity, we'll be declaring all the input and output port, okay. Will be input and output port. So if this is like out, so this is the output port. And in input there are like two types of input. One is simply input, so that is like input for uh, this module. Whereas there is another, it's like input in out, okay. So this act as a both input and output. So basically we'll be using simply in and out, okay. And third one is architecture, right? So architecture is like where we'll be writing the like we'll be using this boolean function, like whichever we have got this, right? So we'll be using this function and design the architecture for this model, so that like so like whenever we send the input, so the like major uh, work of the like some like addition work will be happening on this architecture, okay. So entity is just we will be defining what is our input and what is our output. And this library is like explain, like we'll be defining few libraries, which we need to write that VHDL coding, just like like I think like in every other programming languages, okay. So after once we write the VHDL coding, then we'll go with test bench, okay. So we'll do simulation, because like we cannot directly this deploy this code into FPGA board, because we have to simulate it, and only if once it is working as our expectation, then only it's better to like deploy on the board. So in simulation, what we'll do is we'll pass all the possible inputs, right? All the possible input, like for in our case we'll be like passing all the possible values for A and B, and then we'll be like like we'll be seeing the graph for like how sum and carry are like we like how we are getting this sum and or carry. So if it is if we have like designed our VHDL code properly, then like this I mean like simulation will be what will work as what we have got on that truth table, right? So I mean like if we add 0 0, like sum would be 0 and this. Okay, so now let's jump now let's start writing the code, okay. Okay, now let's go and write the VHDL coding, okay. Okay, so now let's start writing a VHDL code for half adder. Okay, for that, let's create a new project. Okay, we'll name it as half adder. Okay, so I'll do the next. Okay, so here are a few specifications for the project. So we don't need to worry anything about this like config, like we don't have to configure any of this thing. So there's one thing, like in preferred language, there are like two options, either Verilog or VHDL. So we have to choose VHDL over here. And for simulator, there is like iSim, and there are a few other options like model sim. So now in this, for simulation, we have to choose iSim, okay. So other and if you are writing code for some particular FPGA board, then we have to choose the family. Like there are a lot of options. So right now I'll be using like Spartan 6, okay. Okay, so now let's do the next. Okay, these are the description of the project. Okay, so once we get this home page, okay, so now we'll create a new source. Then we'll choose VHDL module. Like either we can go with the schematic, like we can directly draw the schematic diagram of the logic circuits, like which we have drawn before with from the
boolean function which we got from the K-map, right? So we can also go with schematic, but so right now I'll be going with the VHDL module. Okay, so I'll just again name it as half header. Okay, so I'll do the next, and okay, so we just have to do next. Okay, finished. Okay, so once we get this page, okay, I just remove this comment. Okay, so as I have explained you before, right? So like VHDL model can be divided into like 3 sections. So there is one library declaration, okay, and there is like entity declaration, and finally architecture declaration. Okay, so in library declaration, like we have to define few library source library source files which will be needing to write this VHDL code. So as for now we don't have to do anything, just leave it as it is. So in entity declaration we have to define what exactly what are our input and output ports. Okay, so okay, so now I'll just write port. So as I'll just go with the same variable which we had used before. Okay, A and B will be using as input port. Okay, with of std logic type. Okay, so now you don't have to worry about this, what exactly is this standard logic. So these are like some data type. I hope you'll get to know more about what are the data type once you start learning. Okay, further. Okay, so sum and carry as a output. Okay, so again these are of standard logic type. Okay, so here we'll not be giving semicolon because now we have to close this bracket and then only we'll give the semicolon. Okay, for the last line, just remember that. So now this is the where we have to design the we'll be using that boolean function, like to design the half header. Okay, so here we'll be using that our sum would be a XOR b, right? So these are what exactly we got, these are the boolean functions we got from the K-map, right? So then carry would be, okay, a and b. Okay, so it's done. Okay, so now we have to check if there are like some syntax error or some error on the code, then we just have to check first, right? So just to check that, we have to like in view, there are like 2 options, implementation and simulation. But for checking the code, if there is any error, then we just have to go with implementation, and then okay, we have to like click this synthesize std, sorry, xsd. Okay, double click it, so we'll check if there is any error on our code. Okay, so once we get this message, then there is no any error on our code, so we can proceed ahead. Okay, so I'll just like to show you one more thing, like like we have written the code, right? So like even we can see exactly how our logical circuit has been is it like. So for that we can check from this view RTL schematic. Okay, okay, see, so this is the schematic. Okay, see, like if you click over there, I'll just minimize it. See, this is exactly what we had got, right, before from the K-map. Like this carry was like end of A and B, and okay, if I don't know, this must be XOR inside this box, rectangle box. Okay, okay, so now once we are done with this code, now we have to do the simulation. Like we have to pass all the possible values for our input A and B, and then check if we are getting the proper input and output, like sum or carry. Okay, for that we have to like create a new source, and this time we will be choosing this VHDL test bench. Okay, so again I'll be naming it as half at the test. Okay, so once we get this, so this is we are checking that all the half header we have just designed before, right? Okay, so okay, next. Okay, so once we get this come to this page, so we have to comment all the line which has this clock signal, so we don't need this. Okay, for commenting you just have to press Alt plus C. Okay, so Alt plus C. Okay, even here it is. Okay, we'll just even do this also, Alt plus C. Okay, so now here we have to pass all the values for our input variable. Okay, so B would be 0. Okay, so and then we'll wait for like 100 nanosecond. Okay, so we'll just copy this 4 times just to check with all the possible values for our input A and B. Okay, so 0 0 0 1, okay, 1 0 and 1 1. Okay, so done. So now once we are done with this, now we can like now we have to, you know, like in view we have to choose simulation, and then we have to go inside this just click over here, so that you will get iSim simulator, right? So once we get iSim simulator, then we just have to press that simulate behavior model. Okay, okay, so see this, so this is the output of our half adder. So just to fix the view, we just have to press this zoom button. Okay, so this is the output of our half adder. Like if we press over here, then let's check, like see if our A and B are 0 0, then both our sum and carry are 0, right? So if we go here, like if there is a condition like where A is 0 and B is 1, then our sum would be 1 and carry would be 0, right? So similarly with A 1 and B 0, again sum would be 1 and carry would be 0, right? So now when A and B both are 1, then now sum is 0 and carry is 1. So okay, so it is working pretty well. Okay, okay, so this is all about half adder. Like we have like started from making making the truth table. Like from truth table we got the schematic diagram, like logic circuit for the half adder, and using KMAP we got Boolean function for half adder, which using which we have like design the VHDL code, right? So then now we can implement this code. Okay, so this it is working perfectly for in simulation. I mean now this code is ready to deploy on the FPGA board. Okay, thank you. So this is all about half adder. Thank you.